Today we are going to look at evaluating limits graphically. So how can you tell what is the limit by looking at a graph? So first of all, what is the limit? Limit is what value does y get closer and closer to when x gets closer and closer to a particular number. For example, limit f of x approaches 3 means what value does y get closer and closer to when x gets closer and closer to 3, both from left and right hand side. So coming from left side and the right hand side, when x is getting closer and closer to 3, what value does y get closer and closer to? That would be the limit f of x as x approaches 3. Limit x approaches 3 with a negative sign on the right hand side top of 3, f of x would be, this is one-sided limit. This is called left-handed limit. So what value does y get closer and closer to when we're getting closer and closer to 3 from the left-hand side? Okay, and if you have a plus sign over here, that would be right-handed limit. As x is getting closer and closer to 3, coming from the right-hand side, what value does y get closer and closer to? These are one-sided limits. And the limit may not exist, but the one-sided limit might still exist. So here's some examples. The first one, let's look at the graph carefully. We're given some holes, some solid points, some curves, some straight lines. So we're given graph of a function. First of all, we're trying to figure out x approaches -1 from the left hand side. As x is getting closer and closer to -1 from the left hand side, what value does y get closer and closer to? So let us see, coming from the left hand side, when x is getting closer and closer to -1, y is getting closer and closer to +2. The y value is getting closer and closer to +2. Limit x approaches -1 coming from the right hand side. For part B, coming from the right hand side, what y value are we getting closer and closer to when x is getting closer and closer to from the right hand side? When x is getting closer and closer to -1 from the right hand side, y value is still getting closer and closer to 2. Next, limit x approaches -1 f of x. Because both left and right handed sided limits are equal, so if both left and right hand side limits are equal, we can say the limit exists, and it would be the y value that it's approaching from left and right hand side. So in this case, it's coming to, the y is getting closer and closer to 2 as we're coming closer to -1 from the left hand side and from the right hand side. So we would say the limit is 2 in this case. Next, limit x approaches -4 f of x. So let's see, -4. When x is getting closer and closer to -4 coming from the right hand side, the y value is getting closer to 4. When x is getting closer and closer to from the left hand side, y value is getting to 3. So we would say this limit does not exist because we are going to two different numbers coming from left hand side and right hand side. So this limit does not exist. If we were looking at one-sided limits, then those would exist. Limit x approaches 4 f of x. So when x is approaching 4 from the right hand side, y value is getting closer to -2. When x is getting closer to 4 from the left hand side, y value is getting closer to -3. Two different numbers, not the same number. So we would again say the limit does not exist. Let's check our next example. So we're given the graph of the function. First example, limit x approaches 1 from the left hand side. Okay, x approaches 1 from the left hand side. Let's see, x approaches 1 from, oh, that's a -1. We are talking about 1. X approaches 1 from the left hand side. Y value is getting closer and closer to 3. X approaches 1 from the right hand side. Y value is getting closer and closer to 3 again. Limit x approaches 1 f of x, that would be 3. If both left and right-handed limits are equal, then the limit at that point exists, and it would be that number, whatever y value you're getting closer and closer to as you're coming from the left side and you're coming from the right side. Next, limit x approaches -5 f of x. -5, well, we need to check from left and right hand side. Coming from the right hand side of -5, the y value is getting closer and closer to 3. But coming from the left-hand side, coming closer and closer to -5 from the left-hand side, y value is equal to 2. So we would say this does not exist. Limit x approaches 5 of f of x. Limit x approaches 5 of f of x. Again, as x is getting closer and closer to 5 from the left side and from the right side, we are approaching two different y values, not the same y value. So we would say the limit does not exist. Let's check out one more example. So limit x approaches -2 from the left-hand side. That's what this stands for, -2 from the left-hand side. So let's see, x is approaching -2 from the left-hand side. Y value is getting closer and closer to -2. Okay. Limit x approaches 2 from the right-hand side. Again, the y value is getting closer and closer to -2. So if your left-handed limit and the right-handed limit are equal, then that's going to be the limit. Then the limit exists at that point, and that would be the limit as x approaches that particular point. So limit x approaches -2 f of x would be equal to -2 because it's the same number. As you're getting closer and closer to -2 on the x-axis, from left-hand side and the right-hand side, the y values are getting closer and closer to the same number, which is -2 in this case. Example, part D, limit x approaches -4. So it has to be same number coming from left and right hand side. X approaches -4. Okay, so as we are approaching -4 from the right hand side, so for part D, let's see, limit x approaches 4 from the right hand side. That limit is equal to 3. And limit x approaches 4 from the left hand side, that limit is equal to 2, and not the same number. So we would say limit x approaches 4 f of x does not exist. D and E does not exist because it's not the same number coming from left and right hand side. So we would say this limit does not exist. Limit x approach for part E, limit x approaches 3 f of x. Let's see, as I'm getting closer and closer to 3 from right hand side and the left hand side, the y value is getting closer and closer to -2. Notice that f of 3 does not exist. We have a hole at this point, and that's not an issue. Your function may not be defined at that point, at the particular point, but the limit may still exist. Limit at a point x equal to point A is, as x is getting closer and closer to point A, what value does y get closer and closer to? Let's see one more example. So for number 4, part A, limit x approaches 2 from the left hand side, f of x. X approaches 2 from the left hand side. Okay, when x is getting closer and closer to 2 from the left hand side, the y is getting closer and closer to +2. When x is getting closer and closer to 2 from the right hand side, the y is still +2. So if as you're getting closer and closer to that particular value of x, if two y values, two left-handed sided limit and the right-handed sided limit are same, then that would be your limit. So limit x approaches 2 f of x would be equal to 2. Part D, limit x approaches -4 f of x. So as x is getting closer and closer to -4, coming from the left-hand side and coming from the right-hand side, what y value are we getting closer and closer to? Are we getting closer and closer to the same y value? If we are, then that is your limit. If you're getting to two different y values coming from left side and right side, then the limit does not exist. But in this case, as I'm getting closer and closer to -4 from the left side and from the right side, looks like the y value is getting closer and closer to 0. Limit x approaches 5 f of x. Let's see. I'm going to clean up some arrows on the graph so we can see a clear picture. So x approaches 5. That would be coming from the left-hand side and coming from the right-hand side. Both ways, the y value is getting closer and closer to -1. Okay, y value is getting closer and closer to -1 as x is getting closer and closer to 5. All right, one more thing I want to point out here, which I didn't add as a question, but what is f of 2 equal to? F of 2 is equal to 1. When x is 2, what's the value of the function? The y value is 1 when x is 2. Okay, the function, we have a discontinuity here. We have a hole in here in my graph. So the function value when x is 2, it is not equal to 2, but it's equal to 1. And remember, the limit x approaches to f of x, the limit was equal to 2. Okay, so your function may not be defined at the point, but the limit still might exist.